The more discarded batteries, the better. Make a cut. Tear off the plastic casing. Cut it. Tear off the metal casing. Remove the central carbon rod.
That's what we want. Do it in batches using the same method. Got it all done in one morning.
Add the printed plastic rings with holes. One hole at a time.
Cut carbon rods.
Once you've inserted 16 rods, flip it over and set it up. Install another identical plastic ring with holes. Insert carbon rods into the deep holes as well. First, wire some tin to it. For easy connection, use a copper wire to string all the carbon rods together. That's it. The other side is the same.
It took less than an hour to complete the whole process.
Prepare a multimeter.
Carefully check for proper cross insulation. Okay.
No problem. One is not the same size. Make two. Weld them together. Put insulating foam in the middle. Separate the two. Avoid mutual interference. Have a colleague below break it off. And weld it to the top. At the same time as adding a cap to the middle electrode, extend it upwards. To facilitate subsequent connections. The most core component, an acrylic tube, is now complete. Custom made for the reaction wire. Slowly put it in. Just right, seal the two ends of the reaction chamber with an insulating material. Carefully apply silicone sealant. Wait for it to dry, and it will be firm. To ensure a tight seal, discard the 4 screws and place them on the bottom of the reactor. Align with a silicone ring. A 3-bar cover. With 2 terminal output. Connect the wires. Align the fixed rubber ring and the 4 screws. Place the gasket on top.
After tightening the screws,
add an empty one on top. Used as a combustion chamber. Insert the long acrylic tube and all quick connectors. Cut a piece of tubing to export the generated gas. Printed bracket. Blue one on the bottom. Blue one on the top. Cut a small section of acrylic.
Connect the output hose.
Fill with half a tube of water. Make a one-way valve. It can prevent backfires. More safe. Cover the connector. Insert the hose. Connect to the upper combustion chamber. Now, pour water into the reactor. Be careful not to overfill it. Leave some space for the gas. Safe. First, we need something to increase the conductivity of the water. A little bit of salt. A little bit of strong alkali. And a little bit of sulfuric acid.
Add them to the water and stir to mix well. Use a small light bulb to test which has the best conductivity.
The contrast is obvious. The sulfuric acid solution is the best. Add 7 points of sulfuric acid. Inject it into the reactor through the hose.
Connect it to a 12V power supply.
See that? It appears with a single one. It's starting to bubble. Torn off. It's gone again almost immediately. Wipe it again. Yeah, it's there again. Fun. Let's try. Can't waste it. Added a needle. To increase the gas flow rate.
Can it be ignited?
Okay. It's too simple. This simple water electrolysis device produces a hydrogen-oxygen mixed gas. And it's explosive. The temperature is also very high. See? The carbon rods melt on contact. Remove the needle and connect to the combustion chamber above. Prepare a high-voltage module. The output terminals have been modified. It works on a push. First, install it.
Pressing it later can ignite the flammable gas inside. Put a glass ball into the acrylic tube.
Roll it to the rear. The watermelon was borrowed from a friend. The experiment is over. He still wants to eat it. Turn on the power. Input the hydrogen-oxygen mixture into the combustion chamber.
Ready to release.
Still struggling a bit. Be sure to wear safety goggles. Do a good job of safety protection. The watermelon has opened its eyes. It probably won't affect the taste, right?
Wait a while and do it again. Woohoo!